going, guys? This is Rodriguez Repairs here with another video, and today I'm going to talk about the EVAP system. What is the EVAP system? Why was it incorporated into vehicles? And how do you diagnose an EVAP system problem, whether you have a large leak, small leak, a circuit problem with a purge solenoid, the vent solenoid, the fuel tank pressure sensor. I'm going to get into all that, but first I want to let it be understood that in order to understand the system, you have to put all the components together as one. You have to visualize all the components working together, okay? Because of course you have to know the theory of every individual component on its own, but the way to understand it a lot better is to be able to put those components into one visualization so you can see where how the purge solenoid operates, how the vent solenoid operates, and at what time does a purge solenoid operate or the vent solenoid close, and stuff like that I'm going to get into. Okay, so what is the EVAP system? The EVAP system stands for Evaporative Emissions, and it was established because before there wasn't no standardization regarding where do the vapors inside the gas tank that accumulate go. As you can tell, obviously every vehicle has a fuel tank that's displayed here, and whenever your fuel tank is 50% full, it's 80% full, 70 for example, that extra surface area that is not being accumulated by raw fuel become pressurized with fuel vapors, because fuel is very volatile, and that when you increase the temperature, vapors start to accumulate, start to expand the gas tank, and that's why you have a fuel tank pressure sensor that I'm going to get into a little later. But these fumes that accumulate into the gas tank before, they would just be released into the atmosphere. Car manufacturers, like I said, had no standardization with these vapors. They just released them, released them into the atmosphere and kept it going. But eventually the EPA said, hey, this isn't a good practice. We need to do something with these fuel vapors because this isn't good for the environment. Not only is releasing the fuel vapors bad for the environment, but it's also very wasteful, because those fuel vapors that accumulate inside the gas tank can actually be sent back to the engine and be burned as fuel. Okay, and it's very, very efficient at doing that because the fuel is already vaporized. Okay, so that was a target for these car manufacturers, these engineers, were how do I send the fuel vapors from the gas tank that accumulate back into the engine? Okay, so that's what I'm going to talk about. Everything from where the fumes begin all the way to where they terminate, which is in the engine, the intake manifold, so they can be reburned as fuel. Okay guys, before I start explaining what I have here on the board, I wanted to explain the layout that I chose. So I wanted to have this whiteboard seem like it's a vehicle. So if you look at these two squares here, this will indicate the headlights of the vehicle, and these will indicate the tail lights. Okay, so just picture, like I said, everything's visual. Picture the vehicle in this way, and this black line here is going to indicate the separation from the engine bay from the firewall side to the rear of the vehicle. Okay, I chose that way because in most vehicles today, the EVAP components are located in this same layout, within the vehicle. Of course, not in every, it depends from your make and model, but generally in most systems, they're located as so. So before I start explaining, I want to explain the color I used. So everything that's in brown are actual components, individual components. For example, the gas tank, EVAP canister, the intake manifold, purge solenoid, vent solenoid, so they're actual components, okay? Anything that you see in green will be lines and hoses, okay? So got the lines and hoses there. Anything you see in red is computer control, so the powertrain control module, or the PCM, is sending whether it's ground or power to this individual component. So this would be electrical, okay? And the black, I basically just chose to label the components so you guys can see them a little bit better. And just know that this is a fuel tank pressure sensor, okay, or the vapor pressure sensor, like Toyota and Lexus likes to call it. Okay, so that is a vapor pressure sensor. I'm going to talk about what that is in a moment. So just know the layout that I chose and keep that in mind when I'm explaining the individual components. Let's start with the gas tank. Okay, so you have your gas tank. Okay, you have your vapors accumulating here. You started the vehicle is starting to reach operating temperature. The vapors are starting to expand within the gas tank. Okay, one thing's first, you have your gas cap. Everybody knows where the gas cap is located in these cars because that's where you put fuel to fuel your vehicle. Okay, so the gas cap is there. If you ever taken the gas cap out, you're gonna see that the gas cap has a rubber seal on it. And one thing to understand about the EVAP system is that there's 3 points of sealing. Okay, the EVAP system is a potentially fully sealed system. So you got to understand there's only 3 points of sealing. One is going to be in the gas cap, the purge solenoid, and the vent solenoid. Okay, now the gas cap, you put on your gas cap, you make sure it's very tight and it's sealed. Okay, and now these vapors are accumulating inside the gas tank. Where do they go? So just understand that when you put fuel inside your gas tank, you have this check valve here. The check valve basically helps the pump that you're putting gas determine when the vehicle is at 100% fuel level. Once it's at 100% fuel level, the check valve is going to close and you won't be able to refuel your vehicle unless you forcefully keep adding fuel. But that's the reason why your pump stops, because it's indicating that the fuel level has reached its maximum. Okay, so this right here is the fuel tank pressure sensor. Okay, so like I said before, there's fumes accumulating here. As temperature rises, they're accumulating, it's pressurizing the system. So this sensor is basically a sensor a transducer that just indicates pressure, that just measures the pressure that accumulates inside the gas tank. Okay, so just understand that first. I don't want to explain why the PCM or how the PCM controls it, but just understand that that's going to measure the amount of vapor that are accumulating in this gas tank. Okay, okay guys, so remember that our main goal is to get these vapors accumulating in this gas tank into the intake manifold so they can be reburned as fuel. So we have these vapors, these fuel vapors are accumulating in this gas tank, and every gas tank has a source of where the fumes or the vapors are going to travel. Okay, so as you can see here, this is the source. Okay, there's a little float that it's located here. So whenever the fuel level reaches a certain threshold, that a flow is going to, of course, seal up this area here as the fuel level goes up. So this is going to seal, and that's going to allow or verify that no raw fuel gets inside the EVAP system, because we just want the vapors. We don't want the raw fuel, because then you can damage your EVAP canister. So you have this little flow here. Like I said before, fuel level goes up, the distance of the flow is going to go up, and it's going to seal this port so that no raw fuel can get inside the EVAP system. So just keep that in mind. Whenever the fuel level is not at 100%, obviously the float is going to decrease in distance, and it's going to let the passageway be open again so that the vapors can only travel into the EVAP canister. Okay, that's why most bidirectional scan tools, when they have you do the EVAP monitor test, your vehicle has to be 15 to 80% full or 85% full, because you can't have a full tank, because there's not going to be much vapors accumulating if the tank is completely full. So now the vapors are traveling up these hose, and I don't know if you've ever pulled off a gas tank before. Sometimes there can be a line that goes from the filler neck, okay, and you see it probably sometimes running off from the side. Okay, the reason why that's there is because that's going to connect to the main source of the fuel vapors where they travel to the canister, because sometimes fuel vapors can accumulate here. So this is just another form of travel where these vapors can travel. But the main source comes from the tank, okay, and now they go into the EVAP canister. So what is the EVAP canister? The EVAP canister is basically an activated charcoal canister, which inside you have activated charcoal that when the vapors go inside the canister, they get stored for future use. Okay, they get stored, so whenever the engine is ready to accept these fuel vapors according to certain conditions that gotta be met, they're being stored here, okay, until future use. The vapors are accumulating, okay, so now they're traveling up, now they're stored into the EVAP canister. Okay, as you can see here in the EVAP canister, we have our vent solenoid. What is the vent solenoid? Okay, first, a solenoid, whether it's the purge solenoid or the vent solenoid, they're just electromagnetically controlled on and off valves that are controlled by the powertrain control module. Okay, it depends on the manufacturer. Some are ground sided, some are power sided. So sometimes the PCM sends ground to activate the solenoid. Sometimes they send power. Okay, so you gotta figure out in your wiring diagram which kind of circuit you have. But just know that these solenoids are electromagnetically controlled by the PCM, and their valves that either open or close. Okay, the vent solenoid is normally open. Okay, so its rest state is open. Okay, the reason why it's open is because the EVAP system has to breathe. Okay, because if the vent solenoid was closed at all times, then whenever you try to fill up, you will have trouble filling up because there's nowhere for the tank to breathe. Okay, and keep this in mind, just because there's fresh air entering in the vent solenoid because it's normally open, the vapors are still being stored in the canister. Okay, they're not being released. Okay, they're being stored. It's just that there's fresh air entering so that the system could breathe. Okay, just keep that in mind. The vapors do not escape from the vent solenoid. The vent solenoid is basically just venting. Okay, so this is normally open. All right, so if it's triggered by the PCM, it's gonna close. Okay, keep that in mind. It's a normally open solenoid. The vapors have accumulated into the canister, so let's keep running up our system here. So now they're gonna travel up. Okay, and this right here is basically the diagnostic port. Some vehicles have a green cap that indicates the EVAP system diagnostic port, where you can unscrew it. There's going to be a Schrader valve that is reverse threaded, because a lot of people have damaged a lot of these valves because they try to open them thinking it's left-handed thread, and they end up damaging the thread because it's plastic thread. So just keep that in mind. That port is basically so that you can smoke the system, you can pressurize the system, look for leaks and things like that. So that's why I put that the diagnostic port there. Okay, so the fumes are traveling, and now we have another solenoid. Okay, this is the purge solenoid. Okay, and hence the term purge, get rid of, right? So the purge solenoid is normally closed. Okay, unlike the vent solenoid that's normally open, the vent solenoid is normally closed. Okay, so its rest position is closed. Okay, so now you have the fuel tank pressure sensor, or the vapor pressure sensor like Toyota and Lexus calls it. Once this sensor detects that there's a lot of overpressure in the tank, okay, it's gonna send that signal to the PCM, and the PCM is gonna say, hey, okay, let's meet the conditions so that we can get these vapors from the canister and bring them inside the intake manifold to get reburned. So what's gonna happen? The purge solenoid is gonna open. The computer, the PCM, is gonna command the purge solenoid to open for a small temporary amount of time to just take out those vapors out of the canister and put them into the engine. How does it do that? Okay, purge solenoid opens, and what do we have in the intake manifold? We have engine vacuum. Okay, so the same engine vacuum that happens inside the motor is going to help, or is going to basically suck up those fuel vapors into the engine. Okay, for a small amount of time. Okay, because the purge solenoid is modulated. Okay, when the engine requires the vapors to go inside the intake manifold. It's not always doing the job. It's only doing its job when the vapor pressure sensor or the fuel tank pressure sensor indicates there's too much pressure in the vacuum, and when the engine has met its conditions, so that the PCM can finally say, hey, let's open that purge solenoid, or let's modulate that purge solenoid for a small amount of time so we can release these vapors into the intake manifold. Next thing you know, purge solenoid is now closed, and the whole system repeats itself. Okay, and fuel vapors accumulate, they travel to the EVAP canister, they're stored until the fuel tank pressure sensor senses there's too much pressure, or senses that the motor is finally ready and has met its certain conditions to bring the vapors into the intake manifold, and engine vacuum is going to release these vapors into the motor when the purge solenoid is modulated by the PCM. Okay guys, so that's pretty much it. That's pretty much the system. Okay, however, you have the vent solenoid, right? The vent solenoid is normally open, correct? Yes. But why does it have the ability to close? I mean, the valve is just like this valve, it has the ability to open and close according to the PCM. It's normally open, but what's going to happen is this. How does the computer, the powertrain control module, know when there's a small leak, when there's a large leak, when the purge solenoid is faulty, when the vent solenoid is faulty, when the fuel tank pressure sensor is faulty, what's going to happen is, first, you got to verify that you don't have any diagnostic trouble codes that have to deal with vacuum, assuming the manifold air pressure sensor is working correctly, the MAP sensor. But anyways, the PCM is going to do its own diagnostic test on its own system to verify that this system is operating correctly. How does it do that? Well, the normally open vent solenoid is going to be commanded by the PCM to close. Okay? Remember, there's 3 points of sealing: vent solenoid, gas cap, and purge solenoid. Okay? It's going to close the vent solenoid. Purge solenoid is normally closed, so the whole system is sealed. Okay? PCM is then going to command the purge solenoid to open for a period of time. Okay? It's going to open. Okay? Intake manifold has engine vacuum. The whole system is going to be put under vacuum, right? Because the intake is drawing vacuum on the entire system because the purge solenoid is open, the vent solenoid is closed, so now the whole system is under vacuum, okay? And it's going to be measured by the fuel tank pressure sensor because even though the fuel tank pressure sensor is measuring pressure, in this instance, it's going to be measuring vacuum, so it's going to be measuring negative pressure, correct? Yes, so once the EVAP system has reached its threshold of vacuum, according to the PCM, okay, of negative pressure, the purge solenoid is going to close, okay, so now the whole system is under vacuum because the purge solenoid is closed, so now every point of sealing is closed, and now the computer is going to measure that vacuum, and is going to measure if there's any decay of the vacuum over the period of time. Obviously, if the decay happens relatively quickly, that means that this is potentially a large leak, and if the decay happens relatively slowly, that's going to account for a small leak. Remember this: if the system isn't even able to achieve the correct amount of vacuum before the purge solenoid is closed, then that's also going to throw a large leak code. Okay, so remember that. Okay, so the whole system goes under vacuum. The purge solenoid closes, PCM closes the purge solenoid, and now the PCM is looking for a decay of pressure or a decay of vacuum. And like I said, if it does it relatively fast, it's a small leak, and if it does it over a longer period of time, then it's a small leak. Okay, one variance I want to talk about is that some vehicles actually have another extra component in the EVAP system. Okay, and this is going to be a EVAP pump. Okay. So normally it's located between the EVAP canister and the vent solenoid, or somewhere within the line of the gas tank and the EVAP canister. So I'm going to put it right here. So it's basically just an EVAP pump. Okay? So it's basically the same theory when it does this diagnostic test, but in opposite. Okay? So the PCM is going to seal the system, is going to close the vent solenoid, okay, the gas cap of course already sealing, and the purge solenoid is going to close as well. It's normally closed, and the EVAP system, instead of the fuel tank pressure sensor measuring vacuum, is going to actually measure pressure, which is pretty much the same thing. So instead of drawing engine vacuum to put the whole system under vacuum, it's going to close the purge solenoid, and this EVAP pump is going to start pressurizing the system. From this point of the purge solenoid, it's going to pressurize the whole system until the threshold is met from the fuel tank pressure sensor, and then the PCM is going to note if there is a decay in pressure. Okay, it's going to determine anywhere in the system if there's a decay in pressure. The PCM is going to know, and that's how it's going to determine if there's a small leak or a large leak. The same concept, but in opposite. Instead of measuring negative pressure, which is vacuum, you're measuring positive pressure, which is pressure. Okay, one thing I forgot to put, the EVAP pump obviously is going to be controlled by the PCM as well, so just wanted to note that the EVAP pump is basically pumping air into the system to pressurize the system. is going to be controlled by the PCM as well. I just wanted to note that to get it clear for you guys. So now we have determined whether the computer knows if there's a small leak or an evap large leak. Now, how does the computer determine whether the purge solenoid or the vent solenoid are, stuck open, or they, have some sort of debris in them, or they won't close fully, they're rusted, whatever the case may be? How does the computer know that? Well, once the PCM has determined, the decay rate, or has passed the decay test, whether with pressure or with vacuum, the PCM is then going to open the vent solenoid, okay? Taking count, the system is still either under vacuum or under pressure, determine whether you have the evap pump or not, but the system is either under pressure or under vacuum. If the computer opens the vent solenoid, or the computer will open the vent solenoid, there should be an instantaneous change in vacuum or change in pressure, because if the system's under pressure or under vacuum, if you open a point of sealing, which is the vent solenoid, the pressure should instantaneous change, and the computer is going to know that. And if there isn't a instantaneous change in pressure or vacuum when the vent solenoid is open, the PCM is going to set a vent solenoid code, okay, saying that it's either stuck open or something like that, okay? Same with the purge solenoid. The purge solenoid the computer's going to command it open, and there should be an instantaneous change, in pressure or vacuum when the purge solenoid is open, because that's normally closed, okay? And now regarding the fuel tank pressure sensor, or the vapor pressure sensor, that is a 3-wire sensor, okay? Normally you have ground, you have the signal, and you have the 5-volt reference. And the way the computer checks its wire continuity is by the 5-volt reference, okay? Which is standardized in other sensors as well, not just the fuel tank pressure sensor, as well as other sensors in the motor have a 5-volt reference circuit that checks the wire continuity, okay? I hope you enjoyed this video. I hope it was very informative. Leave comments down below and subscribe to my channel, and yeah, just let me know if you found this video useful and what other ideas I could potentially have for future videos, okay? Thank you.